Hi everybody. Let's go ahead and get started. I think I just have one reminder for you today, which is that your first assignment, Unit 3, is due on Thursday. I think that's right, Thursday. I hope I'm right. So if you haven't got started on that yet, you probably want to think about that today. I think there's probably enough time in class today for you to think about getting set up and started on that project. So I would encourage you to talk to your TFs or talk to me about that today if you need help getting started on that, so that you've got time to get it finished before Thursday. I think that's the only scheduling thing that's on my agenda. Oh, I guess one other thing. I'll remind you again on Thursday, but next Monday we're gonna have a guest teacher. So DJ, one of the TFs, is going to be teaching for me on Monday, just to mix things up a little bit. So don't be surprised when you see him here next Monday. I'll actually probably still be here on Monday, unless I have to be somewhere else for other reasons. But I'm planning on being here on Monday. So, all right, today's material. A lot of it actually was review, not all of it. There was definitely some new stuff in there, but there was a chunk that I feel like was probably review. We've seen model view controller before. We did that in Flask, right? So good to reinforce those concepts, good to hit those concepts again, but not super new. We've also seen the concept of debugging before. It's been a while. I don't think we talked about it a whole lot since Unit 1. But it's such an important skill, so I really want to hit that piece a lot today. I think debugging is hugely important, so we're going to talk a bit about debugging and go through a couple of debugging examples at the end of class today. So let's go ahead and get started there, actually. What's a breakpoint? I know this is a question we talked about many months ago, but let's review a little bit. What's a breakpoint? Point where the code breaks? That's everywhere, right? Yeah, okay. So a breakpoint is where we're telling the program to stop. So, it's kind of easy to fall into this idea of when you hit that green triangle, it's like a train, right? It's just, and it's just going down the tracks and there's nothing that's going to stop it until it hits its destination. Well, that's not actually true. We can set a breakpoint in our code. We'll do this a little bit later. We'll go through an example of setting breakpoints in our code, which will make our program stop at that particular point. And what's that allow us to do then? Why do we use breakpoints? What's the big deal? I can look at variables. I can use something called, if there's a particular variable I'm interested in, I can use a feature called a watch. So I can actually type the name of the variable that I'm interested in, or the value that I'm interested in seeing, into the debugger and watch it change as my program progresses. Right? So this is very, very, very useful. What kinds of errors are we trying to fix with the debugger? Logic errors. So what exactly is a logic error? There's different kinds of errors, right? We've got logic errors, which is what? The code runs, but I get the wrong thing back out. I get an answer, a value. Something happens, the behavior happens that I don't expect, I don't anticipate. Right? Contrast that with like a syntax error. What's a syntax error? Yeah, you leave a semicolon off, you forget a parenthesis, you forget a quotation mark, you type a variable name in wrong, forget to put the data type in there, right? How does IntelliJ tell us about those things? It just puts the red, yeah, like spell checker in Microsoft Word, right? It's kind of spell checking your code. It's syntax checking your code for you. So the debugger's not going to help you with that, right? The debugger's not going to help you with those issues. But the logic ones, the ones where you've got some flaw in the actual step-by-step execution of your program, that's where the debugger really comes in handy. That's why it's so useful. So then let's say I set a breakpoint. We're going to do this later, but let's say I set a breakpoint at a specific point in my program, and I run it, and it stops at that point, right? What options do I then have to control the program from that breakpoint? Step over, so what does that do? Or contrast step over to, what's the other one? Step in. So what's the difference? What's the difference? I heard the word dependency. There's a very specific word I'm looking for here. This always makes me think of a very famous rapper whose name starts with, part of Wu-Tang. We've also been talking about these things a lot recently. Method Man? Right? I don't know why, but I always think of Method Man when I think about stepping in, because that's what stepping in does, right? It steps into the method. If I'm calling a method and I want to see what that method's doing, I click step in and it goes into that method, and now I can see how that behavior is actually working. Step over is going to let the method execute and then just skip over all of that, right? So what does that mean for you? If you're going through a debugger, you're trying to debug your program, and you get to a method call, and you've got an option in front of you. Do I want to step into this method, or do I want to step over it? The question really is, how much do I trust that method? Did I write that method? Did somebody else write that method? Or is this a method that Java has provided to me? If it's a method that Java has provided to me, I trust it a lot, right? So I'm probably going to step over it. I'm not worried about how that method works. I'm just going to trust that it does what it's supposed to do. If I get to a method call and it's a method that I wrote, or a method that some other guy I know wrote, then I really am like, well, how confident am I in how well this method works? If I think the method's solid, if I think it works exactly the way that I expect it to, I'll probably just step over it. I'll probably just skip it. Not worried about checking every single line. But if I think that there might be a problem in there, then I'll probably step into that method and view line by line what's going on to make sure that the behavior that I'm seeing, the errors that I'm seeing, aren't related to that method. So I can rule it out, hopefully. Does that make sense? So then if I'm in a method, there's another option that we can use called stepping out. So step out is if I'm inside of a method, it's just going to get out of that method and go back to wherever the method was called from. So it really helps to have an idea of this chain of execution from one method to the next method to the next method to the next method. We actually have a name for that. It's called the stack, the method stack. So at the very beginning of the stack, I'm always going to see the same method. What's the first method I expect to see there? Main. That's always first. Any methods that are called from main, I'll see next in the stack. And then if that next method calls another method, I'll see that one on the stack, and it'll just keep adding them in a chain. So when I step into, that's like adding a new method to that list. When I step out of, I'm removing one. I'm taking one off and going back to wherever I came from. Does that kind of make sense? So really understanding the flow of the program helps us decide, which option is best when running through the debugger. It is a skill. Debugging is a skill, and it's one that I think is very, very, very important. So important that if you start asking me about problems in your code, one of the first things that I'm going to start asking you now is, well, did you debug it? Or I might ask you, where do you think the problem is? I think the problem's somewhere in this line of code or somewhere in these few lines of code. Okay, put a breakpoint right there. See what happens. I want to see you guys giving this a shot. I want to see you guys working through your own code, learning how to put these skills to work. It's so, so, so important. Any questions about debugging? I'm going to do a demo later, but any questions about debugging right now while we're on the topic? Do we have any questions? All right, let's talk about something a little bit different then. Another video from the prepper today talked about Git, and we've been using Git a lot actually in this class as well. We've been using Git ever since the beginning of Unit 2, I think. So some of this stuff is also kind of review, but it's good review. It's good to make sure we understand what these concepts are. So what is the Git Ignore file used for? Why do those exist? So a repository is just a collection of files, right? And when I'm working on a project, I've got lots of files laying around, but the question is, do I want all of those files to be in my repository? And the answer to that question is almost always no, I do not. A lot of them I do. A lot of them I want to be, we want them to be tracked, right? We want to be part of the repository. We want them to belong to Git. But there are other files that we do not want to be included in our Git repositories. Does anybody know an example or remember an example from the prep work of the kinds of files that we might put into a Git Ignore so that they're not tracked? .idea, so what is that file?
Stuff that IntelliJ uses to store metadata.
It's your project file, basically, right? It's an IntelliJ file. The reason that we don't want to track that is because, let's say I'm working on a project with somebody else, or 10 other somebody else's, right? They probably already have a project set up on their computer that's looking at their version of stuff. And so if I commit my project file, it's going to be in direct conflict to that. That's a little bit vague, I realize after saying it, but you know, that's kind of the general theme with Git Ignore files. I don't think it was covered in the prep work as much, but another set of files that I often expect to be ignored are anything that shows up in a folder called bin. Does anybody remember or know what a bin folder is telling us? I'm sorry? Java libraries? Close. Bin is short for a word that we've been talking about a lot. Binary. That's what bin is short for. Not like a bin, like a collection of things, but like a binary. So really, what do I see in the bin folder? I see the binary representations of all of my code. But the problem with that is that the binary representations are going to be very, very different from my computer to your computer to your computer to your computer to your computer. So the versions of my binary files will not look the same as yours. I do not want those to be in the repository because they don't do you any good. In fact, it's going to make your life worse if I include them. So what do we want in the repository? Source code. .java files in this particular case. Or if we're working in Python, we'd want the .py files, definitely. Right? So any folders that contain source code, that's what we want in the repository. Anything that has to do with specific configuration on your computer and only your computer, we want to filter that stuff out. I realize that there still might be, a little bit of unclearness about, what Git files are used for, what should go in them and what should not, but it's another skill that you'll get practice with over time. All right, this is something I know we've talked about in past classes, but let's go over it again real quickly. What's a Git Remote? What is a Git Remote? It's an online copy of our repository. You could say it's in the cloud if you want to, although I feel like people would beat that term to death these days, but it's technically accurate. Git repositories, in order for them to be useful to us, we typically have at least 2 copies. I've got the copy that's on my computer. I've got the copy that's on the internet. The one that's on the internet is a remote. The one that's on my computer we call the local copy. The one that's currently on my laptop. We can have more copies than that, but that's at a bare minimum. I've got the copy on the internet, got the copy on my local computer. So a remote is really just, when you specify a remote, in the video, they showed you how to add a remote to your local repository. What you're doing basically is saying, where does this live on the internet? And the answer to that question 99.9% of the time is going to be somewhere on github.com, connected to your GitHub account. There are other places that you can use, but GitHub is by far the most common, the most popular one. And so this is maybe the most difficult Git concept that was kind of presented in the prep work video. He talked about this idea of an upstream repository or an upstream remote, you might hear it referred to. What is that, or what is it used for? Did you get an idea of what that was used for in the prep work?
Like your personal copy of
Yeah.
Chris made stuff launch code.
Right. So that's exactly right. There is let's say that there is, in fact, a launch code copy of the Java exercises. And one of the first things that we had you do was create a fork, which means I'm taking that launch code repository and making my own personal copy of it. But the question is, well, what if launch code updates their stuff sometime in the future? I want to get that information. I want to get the information that from the original repository, not just have it connected to my fork. In this setup, the launch code version is called Upstream, right? Because my repository talks directly to my copy, but then there's another copy beyond that, upstream, that could also potentially give me new information, push new updates. So if I care about those updates, if I want to use them, we'll add an upstream repository. It's very similar to a remote. In fact, it is a remote. It's just a special kind of remote repository that's also connected to, a repository. So if you want to kind of boil it down, this is maybe a little bit of an oversimplification, but it works for most circumstances. If I have a repository, I've got at least one remote. That's going to be my cloud version of the repository. If I have a second remote, or a third, or even a fourth, those are probably going to be upstream repositories. Those other ones are going to be upstream repositories. And there's a whole lot more you can do with remotes and upstream repositories that was not covered in the prep work. We're not going to cover it right now either, but this is sort of the beginning of Git repository management kinds of stuff. Any questions about that? Any questions? Good? Cool. All right, let's talk about Spring. That was the other big piece of today's prep work that I want to talk to you about for a while. What is Gradle? What the heck is that? What is it doing for us? Anybody know?
Stores dependencies.
Dependencies, okay. Gradle, we call it a dependency manager is kind of how I think of it. So what's a dependency then?
It's a required application program module for the application.
A module, a library, you might hear it called, right? So there's certain pieces of code that lots of applications want to use, or that are very common things that are used across many different applications. And we want to use those too for our applications, right? So basic web stuff, basic web communication stuff, I don't want to have to write that code. It's the same for anybody who wants to do, basic post and GET request kinds of handling. There's a lot of stuff that's very similar or even identical from application to application. I don't want to write all that code. I want to use code that somebody else already wrote. Those are dependencies. So Gradle is a dependency manager. If I know that I'm building a web application, for example, I tell Gradle that I want to use the web library, the web dependency. In fact, that was part of the things that we asked you to do when you set up your Spring project. Remember? There's a box where we have to type in the dependencies. You have to look it up, and one of them was called web, one was called Timeleaf, one was called DevTools, I think, something like that. And so what were you doing? Actually, when you typed those into the box, you were telling Gradle that you wanted it to manage those. The advantage of using Gradle is that those libraries, those modules are in constant development. So if an update happens and I need to update my program, Gradle will automatically go out and fetch new copies of those modules for me. It'll automatically manage those. It'll make sure that if I take my program and I put it on a different computer, that those dependencies, those things that I need for my program to run, will be downloaded and installed on that computer so that the program can access the code that it needs to in order to function the way that we want it to. Right now, Gradle probably just feels like this magical thing that makes our code work, and to some degree it is. That's sort of how I feel about it as well. I don't know a lot about how Gradle actually works. I know that it does work. I know how to use it, right? But I don't need to know how it does all of its stuff. That's not important to me. I just sort of trust it and let it do its thing. The other stuff we do have a lot more control over. So let's talk about things that are more directly related to Spring and to Spring Boot. What kinds of applications are we building with Spring Boot? Web apps, but more specifically, we're going to follow a particular paradigm. MVC, right? MVC apps. So let's talk about how we develop MVC apps, starting with this first question here. What's an annotation? Do we have annotations in Python? Or something similar to annotations in Python? Do you remember? I'm sorry? Comments? Not quite. Kind of like the decorators, yeah. I think Python calls them decorators. I think you're right. In Java, they're called annotations, but really they serve basically the same purpose. What purpose is that? What's an example of an annotation you saw in the prep work? There was at least 3 or 4. RequestsMapper, yep, RequestsMapper. That's one example of an annotation you saw. What did that one do for us? It's like the app route. It's like you're literally setting up the route. Which route is going to be connected to this method? So that's what annotations are used for. I can write Java code, I can write methods, they do all kinds of stuff, right? Annotations then will connect those methods to routes or other parts of our program. That's one thing that we use them for. They can be used for all kinds of stuff. We're going to see them be used in the context of ORMs at some point. Those are going to come back. We're going to work databases back into the mix here at some point in time. So how do I know when something's an annotation? What am I looking for in the code? @ sign. If I see an @ sign, that's an annotation. And generally, what are annotations doing? They're providing some additional context about my Java code. I have a method here, but okay, I see that you have a method. This method belongs to this route, or this method is accepting post requests, or this method is doing, it's not just the code, but what do I want this code to be connected to? How do I want this code to be hooked up to the rest of my application? That's what annotations are commonly used for. So, we saw this, we kind of already answered this. How do we customize the route? We use this special annotation called a request mapping to customize the route. There was another very important annotation that we saw actually as well at the very beginning of a file, usually, telling it that it was a controller. Saw an annotation for that as well. So we're actually physically labeling, here's my controller. Later on, we'll label parts of our code with this is part of the model, this is part of the model, this is part of the model, right? We don't have a model yet, but we will. We don't really have much of a view yet either, but we will. And annotations will pop back up once we start doing, once we start incorporating those pieces back into our application. All right. And we already kind of answered this question as well along the way. How do we specify methods, get versus posts? But let's talk about this last piece here. We talked about 3 different ways to pass parameters into our methods, into our handlers. There's get and there's post. We've actually seen get and post a lot. We did them a lot with Python. The code for Java looks a little bit different. So the differences outside of the annotation are what? So I specify, actually I have an example I could probably just pull up IntelliJ real quick and show you, right? Since I was poking around with this earlier. So you see that the difference between, here is me telling Spring that for this particular method, I want to use get requests. So if a get request comes into this route, I want to execute this handler. If a post request comes in, so you see request method is post now. If a post request comes in, then I want to use this handler, right? That's how we specify what methods use. But if I want to actually access the parameters, if you've been paying attention, you can kind of see. Is there a difference between how I access parameters with get requests and post requests in this setup? No, not really. For a get request, this is a get request. You see that it's, I have this HTTP servlet request object. What does that object do? I don't really know. It's an object that, packages up our request. I don't know the internals of it. I know it's an object that contains the request that was sent to the page. So I access the parameter from that object, request.getParameter. This is what it looks like for a get request. If I scroll down here to look at the post request, you see actually, is that a post request? Yeah. You see actually it's the same setup. And here's my HTTP servlet request, and I say request.getParameter. So Java really, from the coding side, from the back-end perspective, is treating get requests and post request parameters in very much the same way. On the front end, though, they're very different. They still behave exactly the same way that we saw in Unit 2. where GET request parameters show up in the URL and POST request parameters are sent as part of the message itself. It's part of the body of the message. Even though we treat them the same on the back end, they are not the same on the front end, and so it's still important to keep those differences in mind. Then there's a third way that we saw to access parameters. The third way was called URL segments. So what do I mean by a URL segment? What does it actually look like? I put a slash after my route, so the route is the first part, then a slash comes after it, and then what comes after the slash? The parameter that we want. So here's how that was set up in the prep work, and you'll see some more examples of this as we go through. Right? Here's the handler that we want. This is the route. Everything before the first slash, this is the route. The curly brackets indicate to me that we have a parameter embedded in the URL, and the name of that parameter is name. So whatever they type after the slash is the value of that parameter. It's a we didn't actually see how to do this exactly with Flask in Python in Unit 2. This is something that's a little bit new, but flexibility is a good thing. It's a slightly different form of putting things in besides saying question mark equals so and so to type in parameters. And then you can see that in our method, oh hey, what's that again? It's an annotation. Specifically, this annotation is telling us that this input parameter is coming from the path, from the URL. Where do I get this value from? Oh, I get it from here, whatever's in the URL. That's what this annotation is telling us. It's providing more context about how we want these values to be set up. That's why this annotation exists. So it gets plugged in, and then we treat it appropriately. Are there any questions about that? I know it. On the one hand, we're doing things that we've kind of seen before, but on the other hand, they look a lot different now. So let me know what questions you have.
During the prep work, it would tell us to, as we were coding along with it, it would tell us to add certain annotations, and then IntelliJ would want us to import that.
Yeah.
How is that something that will always happen? That does every annotation have an import that needs to be associated to it?
Yeah, so the question was, does every annotation have an import associated with it? The answer is yes, absolutely it does. And you do need to have IntelliJ import those for you. Yeah, that's going to be a thing that will continue to happen. In some sense, while these aren't part of a method necessarily, they still are part of the code. They're still part of Java, and they belong to a Java library. Specifically, if you come up and look at the imports, you can see that where did these come from? Oh, wait a second. Org.springframework, blah, blah, blah. Web. Web is one of the dependencies that we typed into the box and told our program that we wanted to use in our project. And then if we scroll over here, you see that, okay, annotations, right? It's telling us exactly what we're importing. I'm importing this annotation from the web dependency that we set up for our program. What's the name of the annotation? Oh, okay, it's this thing. I want to use that annotation. So yes, you will need to continue doing that. But fortunately, IntelliJ helps us out. I didn't type this out. I wouldn't want to type this out. I wouldn't know how to type this out. That's a lot for me to remember. I don't want to remember it. I got more important stuff to remember. So IntelliJ will help us out. And it's good to let IntelliJ take care of sort of this, you might hear this called like boilerplate, or tedious code that nobody really wants to write, but is still necessary for proper execution. What other questions did you have? Yes?
So those dependencies, those are local on your computer once you're set up, or you tap in there and every time this thing is...
Great question. The question is, are those dependencies living on my computer, or are they somewhere out there on the internet? And the answer is both. When you first set up your project, we don't have those, right? We didn't ask you to install the web dependency. But when we put that web dependency in our project as part of our Gradle setup, what Gradle does for us is it looks and says, hey, do I have this yet? And if the answer is no, it says, all right, let me figure out where to go to get it, and then it gets it. In fact, you probably remember that when you first loaded this project, which is actually something else I want to talk to you about, when you first loaded up the Spring Boot project, one of the first things that happened is that it took a few minutes to download a whole bunch of crap on your computer, right, and set a whole bunch of stuff up. That was Gradle, going out and finding all of those dependencies that we requested and putting them on your computer so that you could use them.
And you were saying it'll, I guess it's have some server turn around to see if there's a more recent version?
Yeah, it will. It'll automatically update. Yep, it'll automatically update if it, every time you run the program, basically, it'll check to see if there's a more recent version of those dependencies out there and grab them if they exist. We call it, sort of centralized dependency management. It's sort of the idea. Back in the, I don't want to say old days because it was like, 15 years ago, maybe at the most. Everybody had to manage their own stuff. So if my program needed something in order to function, I had to go find that something. I had to go download that something myself. I had to put it in the project myself. You can still do that, but it's work. It takes a lot of time. It's work, and it's not very fun either. It's tedious. So Gradle is an example of a centralized manager that we've developed to eliminate some of those tedious parts of programming, make our lives easier, and manage all of that on our behalf. We also had to walk uphill both ways in the snow. What other questions did you have? All right, so I have a couple other things I wanted to show you. It's more demonstrations, I think, than exercises today. I have a couple of demos, but I will ask for your feedback on a few pieces. One thing is, I've already had multiple people ask me about setting up their Spring projects from the prep work. There's a part of the prep work that says, when you load up the project, there should be a box that pops up down here in the corner, and for a lot of people that box never showed up. Well, guess what? It didn't show up for me either. So how do you fix that? What the heck am I supposed to do if that happens? Let me show you if you run into this, or maybe some of you are dealing with this now, I don't know. I wouldn't be surprised. The way to fix this, on your main IntelliJ screen here, once it comes back, come on. Wakey wakey. Okay, on your main IntelliJ screen right here, when you say import project, point directly at the build.gradle file when you import the project. I think the instructions tell you to just click on the Hello Spring folder. But if you actually go into that folder and you point it at this build.gradle project, and then you hit OK, boom. It pops up this window from the prep work. And you can just kind of get through that whole step. So use auto import is what you want to make sure that box is checked, and then hit OK. I'm not going to do this because I already have my project set up and I don't want to mess it up. But if you're having problems getting the Spring project in there, give that a try. I think that should fix it. I'm happy to come around too once you're working in small groups to help you out if you need help getting that set up today. The other thing I wanted to do is just a couple of quick demos with the debugger. I wanted to go through some debugger stuff with you, starting with a couple things. I had a couple exercises in mind. Starting with the studio, actually. I wanted to start with the studio from last time. We kind of didn't, I didn't budget my time very well for the studio, let's put it that way, last week. And so I blew through the last section very quickly, very, very fast. I didn't have a proper amount of time to, explain what was going on. And so I thought, well, all right, let's just go through it real quick using the debugger. Make sure we understand exactly what this code is doing. So first thing is, which part of the program do we actually care about? And we did this last Thursday. I feel like most people kind of get it, but I'd still like to go through it with you real quick. So that's what I'm going to do. I'm going to go ahead and stick a breakpoint right there. And you notice all I have to do is click next to the line number that I care about, and it puts a little red circle there for me. remember, for those of you who need a little refresher, this studio, we're counting characters. So we want to know how many times each character shows up in a piece of text. And one of the ideas was that we were going to use a hash map for this, where the index is a letter, and the key is a letter, and the value is the number of times that it's shown up. So one of the things that we had to deal with is, well, okay, if the letter is not in the hash map, I have to put it in the hash map. If the letter is in the hash map, then I have to get the value out, add 1 to it, and then put it back, is kind of the idea. And so this code works. We actually tested it. We saw that it worked. But how does it work? Let's actually walk through it step by step and see how this actually works. I want to find the first case of a duplicate letter, which looks like LO, is it the M? I think it's the M is the first one that shows up more than once. Actually, I can cheat. Let's just put another M right there. Or we can do this, make it even faster. Okay. So let's run through this loop a couple times and see how it actually works. I'm going to set up the debugger here by clicking the little bug icon. And down here at the bottom, you can see my variables. You saw this in the video as well. These are my variables. You can see that I'm currently stopped at this point in the code. Currently stopped here. Now, loops, I think are, it's very interesting to go through loops a few times to see how they work. Loops can also be a pain in the butt for debugging, because what if the error that you run into is 100 iterations into a loop? That's kind of annoying, right? So there are kind of some tricks that you can kind of sort of try to use to your advantage when it comes to debugging to help out. I'll try and show you a few of those. First, let's go ahead and just step through this program a couple times and see if we can understand what's going to happen. My hash map is right here called counts, and it says size of 0. It's empty. There is nothing in it because we just got started. We just started this out. So here's this little blue arrow is my step. Is that my step over? Yes. So let's go through this loop. Oh, is that step into? Sorry.
Step over to the front, so like down blue.
Oh,
Yeah.
my bad. Step over. Yep. So, hello. All right, cool. So we can go to the next line. We can see how this works. I set a variable x equal to 1. I ask, this line is saying, ask the hash map if this letter is already in there. Well, my hash map is empty. There's nothing in it. It's telling me right here, size equals 0. I know the text is super small. I don't know how to make this text bigger. I'm very sorry. But you'll have to take my word for it. The hash map is empty. It says the size is equal to 0. So the key is not in there. I expect this to be false, which means that when I click the button next, I really hope that it moves past the if statement and goes to this line, right? That's what I hope happens. So let's hit the button and see. Okay, good. That actually worked. Where's it going to go next after I hit this button? It'll go back to the loop again. And I can see counts now has some stuff in it, and if I open it up, I can see that the key is the letter L. I know the text is still small. The key is the letter L, and the value is 1. L has showed up 1 time. So I want to test the other case where it already is in there. Let's go ahead and set that up. So I need to step through this loop a couple more times, right? X equals 1. This time I have the letter C is equal to O, which makes sense. That's the next character. So O gets put in. This time, however, I have another letter O. So this is my third trip through the loop. I have another letter O, and O is already in my hash map. It's already in there. I just put it in. So this time as I step through, I expect this if statement to actually do its thing, right? Grab the value out of the hash map, add 1 to it, and set that value to X. So let's see if that actually works. It does. And now it puts that value back in, and so after this statement, O is matched up with the number 2. It successfully counted. That was sort of the basics of the studio. That was, a big chunk of what we asked you to do in class last time. I think it's nice to see it in action, to see that it actually does what we intended it to do. Now, as I mentioned before, debugging loops can get tedious because I'm in this loop now, and maybe I want to go and look at this code down here. I'd really like to go test this out now and see what this code is doing. But I'm up here, so I need to somehow make it out of this loop. And man, if I just sit here, oh my gosh, that's going to take forever, right? I don't want to do that. That takes too long. Or maybe I care about like the 10th character in this loop or the 20th character in this loop. I don't have to step through every single one. There's actually another option that you can use to your advantage. It's called continue, which is, which one are you? Come on now, where are you at? Show execution point, we already did that. Oh, I think it might be a, is it not on here? Step out, force step into, step over. Where's the one that oh, it's right here. I'm sorry, it's over here. Resume program is what it's called in IntelliJ. I'm used to calling it continue, potato, potato. If I click this button, it starts the program up again, and it will keep running until it hits the next breakpoint. So I don't have to go through each line. If I hit this button here, it continues, and it's gone through one whole iteration of the loop and ended up at the next breakpoint again. One whole iteration, one whole iteration, one whole iteration. So now I can check bigger chunks. This is especially useful for loops. I can check bigger chunks of code at a time, so I don't have to walk through every single line of the loop. Or let's say, for example, that I'm satisfied that this loop works, but I want to move to a different section of the code. I can come down here and turn this breakpoint on, and then come back up here and turn this breakpoint off, and then hit the resume execution. And now it just went ahead and did this whole loop and stopped me down here. So you can turn breakpoints on and off at any point in time. That's a very, very useful part of debugging. So if you're looking at a section of code, you're like, all right, I think this works, I'm ready to move on to the next thing. Turn those breakpoints off, set another breakpoint later on down the line, hit the resume button, and it'll take you to that next spot. That is a very common way of attacking a problem. And now we're down here at this loop, and we can see this loop is meant to iterate through and print things out. You can see our hash map's very big now. Looks like it's got 32 characters in it with various counts. So that loop did what it was supposed to do. And if you want to step through this, you can. Right? Any questions about that? There was one other thing I wanted to show you, but any questions before I switch to my last example? Got really dark here.
It's a storm, yeah.
All right. One final example has to do with the Gradebook, specifically the hash map version of the Gradebook. A few people asked me about, was it this section? Yeah, it was this section right here. A few people asked me about this section of this particular example. Specifically, there's a next line down here that seems like, why do we need that? Why is this here? I know I've already explained this to a few people, but we can actually use the debugger to show us why we need this, why this line of code that seems a little off is necessary. So to kind of give you an idea, right, we are asking them to type in the name of a student, and then we're asking them to type in grades for that student. We're asking them to type in the grades for that student. What we can do is set a breakpoint somewhere in this particular section, right? Set a breakpoint somewhere in here and walk through this and see how this is actually working. So I'll set a breakpoint right here so we can step through this section and see what's going on. Oops, did I run the wrong thing? I did. Sorry about that. I ran the studio again. My fault. Okay. So it wants me to type in the name of a student. That's the first thing, all right? And now we're at the breakpoint. We are at the breakpoint. So it's about to ask me to type in a grade. So I'll say step over that. Now I actually have to type something in. So I'll go to the terminal. Oops, not the terminal. The where did the thing go that I want? Oh no. Here we go. Sorry about that. I'll type in the grade. It's looking for a number, like a GPA, right? So I'm a pretty good student, but I wasn't that good. I'll type in 3.5. And let's take a look actually at the, now that we've hit our debugger again, let's take a look at the, if I can get my variables back up here. To the left of the console, thank you. Let's take a look and see if we can figure out what's going on. So I typed in a grade. It looked for the next double value, which should be 3.5. That is a double value, right? My scanner's right here. It's called in. And I wouldn't expect you to know this, but if you look inside the scanner, you see this very first thing. It's called buff, which is a written record of everything that's been typed into the keyboard and sent to the scanner during this program execution. You'll notice that there's my name. That's the first thing I typed in. There's a thing that comes after it, /n. What is that? That's a new line. Then there's the 3.5 that I typed in, and it's another /n. It's another new line. Where did those come from? When I hit the enter key. When I hit the enter key. So why does this line exist here? The debugger is showing us. It read in the 3.5. The position is at 8, actually, and so you could even count 8 characters. 0, 1, 2, 3, 4. The n is actually 1 character, so that's 5, 6, 7, 8. It's on the 5. That's at position 8. It's on the 5. It hasn't gotten through this thing yet because /n, it's not a double. It's not part of a number. New line is not part of a double. So it didn't get read in when I called next double. So what does this line do? It just throws it out. Throws out that new line character that's at the end of my string. It's a little bit inconvenient, right? It's a little bit, you might call it clumsy or awkward. I would actually agree with you if you wanted to describe it that way. But it is a necessary part. And I can show you, right, if I step through and I say in.next line, the position moved up. We're now at position 9, which is at the very end of the string, so that when I start typing in the next grade, it'll pull in the next number. It won't be looking at that new line character. Does that make sense? I hope. I hope. So this is just another way that the debugger can help us out. In this particular case, we had a piece of code that worked, but we didn't quite understand why. Well, run it through the debugger. Take a look at the variables, see what values exist, and watch how they change over time. And I'll show you. I'll show you how it works. What questions do you have for me? Any questions? Okay, that's all I had for you today. So today, 2 main priorities, I think. Actually 3, I guess. If you haven't got the Spring Boot stuff set up yet, the Spring Boot project set up, you probably want to get that done before you leave here today. Let us know if you got stuck along the way. If you need some help getting that project set up, we can get you set up. The studio, of course, you should take a look at that today. Can't do that until you get the Spring Boot project set up. So you got to get the Spring Boot project set up first, then you can do today's studio. And then definitely think about homework as well. The, I forget what, tech jobs, yeah, thank you. The tech jobs assignment that's due on Thursday. So those are the 3 things that you can work on. We'll regroup at 8 o'clock like we usually do to talk about the studio. See you then.